Hello again. In this video, we're going to be talking about graphing linear inequalities. All right, so what are linear inequalities? So we would say that these are mathematical statements in two variables that allow us to compare things that are not simply equal. So far, we have been dealing with an equal sign in there, and we're really used to being able to solve equations with the equal sign. But now we are throwing in the greater than or less than sign, or greater than or equal to, or less than or equal to. And we did actually practice these a little bit in Unit 10, but remember that they only had one variable. So we would have, x is greater than -2, and x is less than 5, something like that. Here we actually have two variables. So we have this linear, kind of a linear inequation, but with inequality signs. The solution for linear inequalities is a shaded region. It's a shaded region with lots of options for solutions. And we use the coordinate graph to graph these, because graphing is a really helpful way for us to visualize the solution of inequalities. When graphing them, we need to look really, really closely at this sign. It's really important. The type of line that we graph is going to be dictated on the sign. So if we have a greater than or a less than without the or equal added to it, we're going to have a dotted line, because that's saying that all of the solutions are either above this line or below this line, but they do not include the line. If we have that or equal to added to those signs, then we use a solid line, because we're saying, okay, the solutions are everything below this line and everything that's on this line, or everything above this line and including all of the points that belong on the line. So to be really, really careful of looking closely at what the sign is to decide what our line will look like. The other idea that we need to be careful of is, where do we shade? Well, if we have anything that has greater in it, so whether it's greater than or equal to, this word greater, well, we kind of know that greater means more, right? So it's above. Greater is above. And if we have less than or equal to, we will shade below. Less kind of means, not as much, or below a certain amount. That's kind of how I remember them. Now, I know that your NROC videos show more steps involved for solving inequalities. I kind of happen to disagree with them, so I'm going to teach it my way. If you guys like how they teach that on the NROC videos, that's totally fine. You're welcome to work these however you feel confident. In terms of the steps here, step number 1, I want you to graph the boundary line. Okay, and that's what they mentioned as well. But they asked you to just kind of pretend that the line is an equation, so it's an equal sign. And you're going to graph that line. And then you actually go to take a look at the inequality sign, and then decide whether it's going to be shaded or dotted. Well, I just don't understand that, because if I need a dotted line, and I've already graphed a solid line, I got to go back and I have to do some erasing in that line to make it a dotted line. So I always ask that students choose the correct type of line before they graph, which means looking once again back up here at what our sign is, right? Whether we're going to choose a dotted or a solid based on our sign. All right, so next we're going to shade the correct region. And of course, we know, like we talked about as well up here, we're really looking at these words. Greater than, well, that means that we're going to be shading above. So either greater than or equal to. Less than or equal to, we're going to shade below that line. And then once we've shaded, this is a little bit different as well. I like to have students shade first, and then we just check 2 points. and just to make sure that we are that we've shaded the correct region. We can check one sign or 1 point, inside the shaded region and 1 point outside. And of course, we're going to plug both of those points into the inequality and do the algebra and see if the expected solution is true. We would expect the one outside the shaded region to not be true, and we would expect this one inside to actually work and be true. So that's what we're checking. I know that oftentimes and on NROC they teach you to choose your 2 points, one above and one below the line, to know where to shade, and that's okay too. You guys can go about it that way. I'm going to talk a little bit more about that here in just a minute. I do want to remind you guys to be careful, right? Be careful when we're working with inequalities. We know that when we multiply or divide by a negative, we have to flip the inequality sign. So just a reminder, I know that that was talked about in Unit 10, and it's also true here in Unit 13. Okay, so this example question here kind of demonstrates this idea of picking our 2 points. Now, this one asks us to determine whether the ordered pair 3, -4, I should say ordered pairs 3, -4, and -2, 1 are solutions to the inequality. So what this is really asking us is just to plug in our x, or plug in 3 and -4 for our x and our y, and we're going to try both of them to see if they work. Okay, so we can do that. Let's actually bring this equation down here. 6y minus 3x is less than or equal to -6. Okay, so let's try this first point. I'm going to just call these 1 and 2. We're going to just start with the first point here. And we're going to try. So our y coordinate looks like would be -4. And sorry for switching colors. I just think that it makes it a lot clearer to see. -6, there we go. So we've got a -24 minus 9 less than or equal to -6. So it's going to be a -33 is less than or equal to -6. Well, when we think about a number line, -33 is definitely less than -6. So for number 1, this is definitely true. So 3 and -4 is definitely in that solution region. Let's check the second point. So this time our y would be 1. And our x is going to be -2. Less than or equal to -6. So that's going to be a 6 plus a 6 is less than or equal to -6. So 0 is less than or equal to -6. Well, I know that 0 is above -6 on a number line, so this is false. So we know that this point here, -2, 1, is not on that, in that shaded region. It's one of those situations where we think about up here, and we talked about how we check 2 points, right? We're checking one inside and one outside the region. Well, this would kind of be how we would do that. We would check and say, all right, well, this point would have been one that was inside the region, right? Inside the shaded region, so inside of our solution, and the second one would be outside. It would not be true. So in some curriculums, they want you to actually, choose 2 points and then decide after you've graphed that line. Now, I want to make a point here about graphing this line. So if I were to kind of just do that, just kind of go through the steps of graphing this, minus 3x minus 6. I mean, you could use x-intercepts, y-intercept to graph this, but I would be super careful. It's not the case in this one, but if you ever have a negative coefficient right here, it means that when you go through and you do your dividing to write this in the standard form, of course, the slope-intercept form, you're going to be having to flip that sign. And so I would recommend when you guys are working with these inequalities to rewrite them, before you graph them, rewrite them in slope-intercept form so that if you need to flip that sign, then you're aware of that right off the bat. Minus 6. In this case, we had a positive coefficient, so the sign still holds true. 1/2 x minus 1. All right, so here is our inequality. And so we're going to go ahead and graph that. So our y-intercept is at -1. I'm going to use a different color. Zoom in a bit. Here's our y-intercept at -1. Our slope is 1/2, so for every one we rise, every rise of 1 we run 2, positive, right? Up 1/2. Or we could go negative on our rise and negative on our run, which is also a positive. Now, before I draw my line, before I connect that line, I want to look closely at this sign. This sign has an or equal to, right? So I know that that's saying that the line is included in the solution. So when I draw this line, I'm going to do a solid line because I know that it's part of my solution. Okay, so that is one consideration, right? We know that it's solid because it has the or equal. The other idea is that a less than or equal sign, the word less, signifies that we shade below. So we're going to shade below this line. Okay, so if this were a problem where I was asking you to graph and then you were doing a check, then you would have gone kind of the opposite direction than how we started this original problem. You would have thought, okay, I need to check a point inside my solution region and outside my solution region. And we can see here that -2, 1 is right here. So here is -2, 1. Whoopsie, don't know what happened there. And over here we have 3, -4. 1, 2, 3, 4. 3, -4. And you can see that 3, -4 is definitely in that shaded region below. And we found out that that was true. And the -2, 1 is not. It's false. It is not involved in that solution. So you know, this idea or this task of sticking numbers in, plugging them in to find out whether they are solutions to an inequality can be just for the sake of doing that, just because that's what the question asks you. Or you also can use that as your check. You're just picking a random point outside, a random point inside, plugging it in algebraically and seeing if it worked. All right, let's do a few more problems from your worksheet. So you notice that the directions ask you to graph the boundary line, shade the solution area according to the inequality sign. Okay, and then you can pick your 2 points to check. This says or, but I would recommend that you do it in addition. Okay, this one is already written as a slope-intercept in the slope-intercept form, so that's helpful. Okay, so let's take a look at our sign here. Looks like we have a greater than or equal to. So what does that mean? Well, greater than or equal means The equal part means that it's a solid line. And the greater than means we're going to shade above. Okay, that's in terms of our shading. This is in terms of the type of line that we're gonna choose. All right, let's graph this. So here we have our B down here at -2, and we're going to use our slope of -2/1. So I can either go down 2 and a +1 or up 2 and a negative. Either way, I'm good. And I've already decided that I need that solid line. Okay, and I know that I'm going to be shading above. And that's it. All right, let's skip down to problem number 4. Okay, here we have an equation that is also already written in slope-intercept form, so that's actually nice. Let's take a look at our sign here. Sign, or inequality sign, is a less than sign. Okay, so let's look at that here. So we know that a less than sign is going to equal a dotted line, because it doesn't have that or equals to, so the line is not included. We also know that a less than sign is below. Okay, we're shading below. So now we kind of have a plan here, and we can go ahead and graph this line. Looks like our y-intercept once again is down here at -2. Our slope is 1. So what that really means is 1/1. So I'm going up 1 and +1, up 1, +1, or I can go negative and -2. Doesn't matter. All right, and I need a dotted line. So I'm just going to kind of try to sketch as best I can a dotted line there. And it's less. So it means it's below, it's underneath or below this line. And you know, we can take the time then to do that check. We didn't do that on the first one, but let's actually do that here. Let's take the time and do a check. Let's pick a different color here. So I'm going to just choose a point that's in my shaded region. How about we do 5, 0. We'll make this nice and simple. Get a 0 in there, which makes the math simple. Oh, this will be really simple. Let's choose 0, 0 here, which is really simple. Okay, let's try both of those. So we're going to try, first of all, 0, 0. And we have to remember that this is outside. So what do we expect here? We expect it to be false. We're hoping that it's false because we don't have it in our shaded region. So we're going to stick in a 0 for our y. We're going to stick a 0 in for our x. And it says that 0 is less than -2. False. False, false. It is not less than -2, but we're happy about that because that's what we expected, right? So we're super happy that that didn't work. All right, and of course, 5, 0 is inside our solution region. So what are we expecting here? Well, of course, we're expecting it to work, right? So we have 0 is less than 5 minus 2. 0 is less than 3. Yep, that's true. And once again, we are super happy. What that tells us is that we shaded the correct location, the correct side of that line below, and we're good to go. All right, moving on. Let's take a look at number 7. Now, if we take a look at this problem, we can see that it is not written in the slope-intercept form. And like I had mentioned earlier, it's always a good idea to do that just so we don't run into trouble with our sign. right, in case we need to flip that. So let's go ahead and rewrite this equation, or this inequality. We know we need to bring this 5x over to the right. I'm going to have to move horizontally, which I don't really like to do, but this is what we're going to have to do. Negative y greater than or equal to negative 5x plus 5. And we can see here that we do have this negative 1 in here. So we're going to have to divide everything by negative 1. And of course, because we're dividing by negative 1, we're flipping that sign over. Okay. So now y is less than or equal to 5x minus 5. All right, so now we have something that we can graph, that we're pretty confident about the fact, we are very confident about the fact that our sign is going to be correct, which means we're going to be shading the correct side of this line. Okay, so looking at our sign, less than or equal to, we can come back here and we can say, all right, well, we know we've got the or equal to, so we know it's a solid line. Less than, we know it's below. All right, so let's go ahead and graph this. It looks like our y-intercept is at negative 5, and we have a slope of 5, or 5 over 1. So we're going to go up 5 and over 1 positive. Up 5 over 1 if we wanted to do two of them. And we just decided that we needed a solid line, so we're good there. And below, I know this line is almost vertical, so sometimes it's hard to kind of decide, ooh, what does it mean to be below that? Well, what I would do is just pick where your y-intercept is, and you know that below that has to be involved in the shaded region. So that means this whole, okay, that's super messy, I'm not going to do that. This whole right side is considered below. Because we can see that, right? If we extended this on down, it would include your negative 6, negative 7, and all that, right? And then, of course, pick your 2 points. And like we did last time, pick some easy points. This is, 0, 0 is always a great one. And pick something here on your line. This one would be good, 4, 0. When you plug that in, it's going to be super easy to do the algebra. And you can check that. All right, lastly, I wanted to go over number 9. So this is an interesting equation, first of all. Oopsie. I'm just going to get rid of that there so I can have some room. Y is greater than 5. Okay, so I know we talked in an earlier video about this. We don't have the x. And what that really means is that x, y is always 5, irregardless of what that x is. And that's because the slope is going to be 0, right? The slope is 0 on that. And that would make sense is if we had, let's just show that. Oops, I'm not real sure what the heck is going on with my screen here. Sorry, you guys. If we showed that y is greater than or equal to a slope of 0, and then any x that we stuck in there, didn't matter. It doesn't matter if my x is 1 or my x is 3 or my x is negative 5. It doesn't matter. It's always going to go away, and I'm going to have 5 as my y, as my answer. Y, when x is negative 1, well, 0 times negative 1, my y is still 5. When my x is 3, well, that's going to go away. My y is still 5. Doesn't matter. All of these points are still going to be 5. So it means that this line is going to exist along y is equal to 5. Let's just pay attention to our sign. We have a greater than or equal to. So we know we're going to have a solid line. And greater than means above. Okay, so we're gonna go ahead and draw our solid line here. Not a whole lot of room here, but we're gonna shade above. And I'm gonna just throw out another scenario. I know this problem only has that one inequality here, but let's just say we had an additional inequality. Let's say we had x is less than 3. Okay, well, in this case, it doesn't really matter what y we put in. X is always going to be less than 3. Okay, it doesn't matter. So what we're going to do is we're going to go to, let me just use a different color in here. It means that x is always going to be 3. There we go. Take a look at our sign. Less than. Okay, what does that mean? Well, it means that we have a dotted, first of all, because it doesn't have an or equal, so it doesn't include that line at x is equal to 3. And below, because we have the word less. All right, so we're going to just have a dotted line going here. And in this case, we're not talking about our y's, we're talking about our x's. So all of our x's that are below 3 need to be in that solution region. So that's why we know we're going to be shading that left side of that line. Okay guys, and you have a few more, of course, on this worksheet to try, and you've got, of course, the solutions with the graphs on them. So just keep working on these, and you will use this knowledge of these inequalities, graphing these inequalities in Unit 14 when we talk about systems of inequalities. You're going to be doing some shading as well, but you're just going to be doing shading for 2 different inequalities. And we're looking for a solution where the overlap of the shading region is. So it's just going to build a little bit further on what we're talking about here. All right, guys, take care. Talk to you soon.